Now we're going to talk about systems of equations with three variables using elimination. And you can see that I have three equations because I have three variables. It's important that all the x's, the y's, and the z's all be lined up with each other. It just makes everything a lot easier. These are all kind of in standard form, so it's going to be a relatively easy thing to do. Now, the goal of elimination is to eliminate variables, but I can only eliminate one variable at a time usually, so what I'm going to have to do is just pick two equations to start with. So you can start with the top two and then do the bottom two, but if you look at the equation that we have here, the first one and the last one together would make a good combination because they're very similar to each other. The 2's in front of the x's already. We can just simply change the signs of the second equation in order to make it so that the numbers in front of the x's are identical. And that's just helpful because now I can just subtract these two equations. So I'm going to kind of ignore this middle equation altogether. And I'm just going to subtract the first and the last equation. Now 2 minus 2 will get eliminated. So that'll get me 0x. That's my goal. 5y minus a negative 2y is 7y. Negative 2z minus 4z is negative 6z is equal to 15 minus a negative 4 is the same thing as 15 plus 4 is 19. And this is my first new equation. Now if I go back to the original, I need to pick two other equations to do. It doesn't matter which ones I do. I'm going to go ahead and do the first two because those ones will be relatively simple. I can multiply the top one by 3 in order to get the equations to be the x's the same. We want to eliminate the x's again. So if I multiply the top equation by 3, this will no longer be a 2, it will be a 6, this will be a 15, and this will be a negative 6, and this will be a 45. So this is going to be my new equation that I can use elimination on. I'm going to go ahead and use elimination with the top and the bottom two, kind of ignoring this last one for now. So 6 minus 6 is going to cancel. That's the goal of doing this. 15 minus 6 is going to be 9y. Negative 6z minus positive 6z is negative 12z. And 45 minus 12 is going to be 33. Now you see that I have two new equations, and if I messed up any of those numbers in the original subtraction, then that could be a really big issue because now I'm going to have two new equations that I'm going to have to do that I will, if I screwed them up, then obviously the whole problem is not going to work. What I'm going to look at now is doing elimination on these two guys, and so I'm going to multiply the top of this equation by 2 because that'll make my z's the same, and that'll get me yet another new equation. So instead of having a 7, what I'm going to have is a 14, a 14y, a negative 12z, and I'm multiplying it by 2, and 2 times 19 is 38. So now what I have is a new set of equations where the z variables are the same, which I can eliminate using subtraction. So 14 minus 9 is 5y. Negative 12 minus a negative 12 is nothing. It cancels out. That was the goal. And 38 minus 33 is 5. 5y equals 5 is very simple, giving me one of my answers of y equals 1. I'm going to go ahead and write that off to the top up here because it's kind of important that we know that. Once we have y, or one of the variables, any of the variables, what we can do is plug it back into one of the original equations. But the problem is I can't plug it into an original equation and help me with anything because there's still two variables that are unknown. So what I'm going to have to do is plug it into one of my new equations, the ones that I just did. I'll go ahead and do the bottom one. It doesn't really matter. And so we'd say 9 times what y is, which is 1, minus 12z is equal to 33. See, I only have one variable in this equation now because I know y, and this is not a hard thing to solve. 9 minus 12z is equal to 33. Subtract 9 from both sides. Negative 12z is equal to, this is 24, and then that'll make z is equal to a negative 2. Now that is the second of my variables that I know. I still am missing one other. And so I have 2. I can go ahead and plug back into one of these 3 original equations. And it doesn't matter which of the original equations that you plug it back into. So I'm going to go ahead and plug it into the, why not the top? That's easy to find. There goes the y, goes in there. The z goes in for the z. And then we'll have a new equation that comes out of that. So we'd have 2x, which I do not know, plus 5 times y is 1, minus 2 times z is negative 2, equals 15. And this equation, while long, is still relatively simple to solve. It says 2x plus 5 times 1 is 5, minus, well, that's really a plus 4 because it was a minus a negative 4, is equal to 15. 5 plus 4 is 9. 2x plus 9 is equal to 15. Subtract 9 from both sides. 2x is equal to 4, and therefore x is equal to 2. This would be my last solution. X is equal to 2. So my final answer would be written as an ordered triple, which would be x comma y comma z. So that would be 2 comma 1 comma negative 2 would be my final answer for this problem.